Hey everyone, welcome back. In this lesson, we're going to start a new but somewhat related topic to the things that we've been talking about. Thus far in this unit, we've been talking about exponents, a little bit of exponent laws, and then we went into talking about squares and square roots and cube roots and things like that. And those ideas are all sort of related to one another. We started with exponents, we talked about squaring numbers and cubing numbers and things like that, and then we explored how to do that same process but in reverse. So how to go from, something like 256 and figure out what number do I have to square in order to get to 256. So basically, if you think about it, what we started with is, let's say you had a number like 2, and you wanted to figure out what 2 to the exponent 4 was equal to. So we wanted to know this. 2 to the exponent 4 is equal to what? Alright, so that's basically where this whole process started. What does it mean to write down something like this? How do we work that out? And we eventually got to something like this, and we would be able to get our answer, which would in this case be 16. Right, so we started with you've been given the base and you've been given the exponent, and find out what it's equal to. And then if you think about it, what we were really doing in disguise when we were talking about square roots is if you had some number, I'll just put that as a question mark, some number squared is equal to 256. So if you had something like this, some number squared is equal to 256, what is that number? And so that was where we figured out that, okay, in order to get rid of the square here, I needed to take the square root of this side, and I needed to take the square root of that side. So that means I'd be left with my question mark, my something, is equal to the square root of 256, which we then learned how to calculate, and of course we get that our answer is 16 in that case, right? So we've dealt with, you're given the base and you're given the exponent, what's the answer? And we've also, in disguise, not to quite the same extent, but we've also in disguise talked about you're given the exponent and the answer, what's the base, right? What we've basically done, we only really did it with squares and a little bit with cubes, but we've done it so that it's like, I've given you that the exponent is a 2, let's say, because something squared is equal to 64. What's the number that I had to square in order to get 64? And so the answer to that would be the square root of 64, which would be 8, right? So we've explored those two ideas. So basically, let me make a little bit of a table here. Apologies if you were in the middle of writing any of that down. That's just a bit of a recap from last time. But so basically what we've talked about so far is, if you want you can make this table, but you don't really have to. So this is base, exponent, and the answer, the power, if you will, as our answer. So if we had some number a to some exponent b is equal to something, some answer c, this table is going to sort of break down what topics we've covered and what we can still explore. So the first thing that we were doing when we were squaring numbers, cubing numbers, raising them to the 4th power, the 5th power, the 6th power. So the things that were on your first assignment where you had like 7 to the exponent 4, that was, in other words, so if you had something like 7 to the exponent 4, you've been given the base, yes. You've been given the exponent, yes. And you have not been given the answer. So that's your job, is to find the answer, right? I've told you that for like 7 to the exponent 4, for something like that, you've been given the base, right? Your base is that 7, your exponent is that 4, so we've been given the base and the exponent, we just haven't gone ahead and actually found the answer yet. So that process was exponentiation. That was what we were dealing with to begin this unit, right? We started with exponentiation. And then we ended up going sort of backwards, where if I gave you something, I'll put a little question mark, something squared is equal to 64, let's say. In this case, I've given you the answer, right? I've given you that answer to that exponentiation problem is 64, and I've given you the exponent. We only really dealt with it when the exponent was 2, sometimes 3, but generally you were given the answer and you were given the exponent, and you had to figure out what the base was. So that was the thing that was not given to you, and so that was, I'll just call it roots here because I'll use the same terminology that we've been using so far, so like square roots and cube roots, right? So we've done exponentiation, we've done square roots and cube roots, so we've talked about when you've been given the base and the exponent and you need to find the answer, and we've talked about when you're given the exponent and the answer and you need to find the base. If you wanted to plug it into a calculator, this exponent could be anything. It doesn't have to be 2, it could be 4 or 7.5 or whatever, it doesn't matter. Your calculator would be able to figure that out. It's just, it gets harder to do by hand is all. So, so we've covered those two things, but what about if you were given the base and you were given the answer and you were not given the exponent? That's the last possible case here, right? If I had to give you two pieces of information, what do you do if I've given you the base and the answer and you need to find the exponent? What's that called? How do we write it down? That's something that we haven't talked about yet, and so that is the subject of this lesson and the lesson or two that'll follow this one, which is called logarithms. You might have seen this before. You don't need to write it down here in a table. I'm going to rewrite it up here as our title for this lesson. Oops, I was writing LE for lesson. Logarithms. So that is our new topic for this video and the next 1 or 2 videos, and then we'll have a test review, and your exponents and logarithms test will be coming up shortly after that. But before we get into test stuff, let's actually figure out what logarithms are. Let's explore what they are and learn a couple of neat properties about them. We'll do some practice questions, all of that good stuff coming up possibly in this lesson. I mean, I've written out a whole bunch of things that I want to get through. I just don't know if I'm going to get through all of them in this lesson specifically, or if it's going to spill over into the next one. So basically, if we stick to the same one example so you can sort of see what I'm talking about more clearly, when we started the exponentiation unit, it would have been something like 2 squared equals what? That was our exponentiation bit, that you have the base, you have the exponent, what's the answer? Then we went to something. I could put a question mark, you could put an x if you like, if you're comfortable with that, because we're going to end up using x and y a lot more in the not so distant future. Then we went to something, some unknown number, squared is equal to some answer. I'll just, for the sake of consistency, I'll make it the same question, right? So for the first one, it was 2 squared equals what? Now it's, then we switched to what squared equals 4. Right? And to get that answer, you would need the square root of 4, which is 2, is your answer for that question mark over there, right? So we started up here, then we switched to this. Now what I'm asking is 2 to the exponent what? 2 to what exponent is going to give me an answer of 4? That's basically what we're dealing with when we're talking about logarithms. So let's break that down. I'm going to get rid of these first 2 lines and rewrite that bottom line up here. So we're basically dealing with 2 to what exponent, that's a question mark in there, is equal to 4. Right? That's this is the setup that if you are given the base and the answer and you have to find the exponent, you're going to use a logarithm. So basically the question that a logarithm is asking, if you want to write this down so that you sort of have it in words, is how many of one number like one type of number do we have to multiply to get another number. So that's basically the question that we're asking here. I hope you can see that all right. But yeah, so basically the question that we're asking when we're working with logarithms is how many of one number do we have to multiply to get another number? Alright, so basically if you look at this example up here, we know that we're going to be multiplying a bunch of 2's together to get some target answer. Could be a 4, could be 64, could be 512, I don't care. Basically the question is how many times do I have to multiply 2 by itself to get that target answer? So notice how that's different from the things that we've been doing before. Before I was telling you this is the number that you're multiplying, this is how many times you're multiplying it together, what's the answer? And then we switched into square roots and stuff, which is here's the answer, and to get this answer I squared some number. What number did I square? So that was the second thing we did. Now I'm saying you have a whole bunch of 2's. How many 2's do you have to multiply together in order to get 4, or in order to get 32, or in order to get 256? So I'll show you the notation. I'm going to rewrite the same problem for the third time over here. So it's 2 to what exponent is going to give me an answer of 4. That's the question that we're trying to answer, but I'm going to show you the way that we use the mathematical notation to write this down more properly than with a little question mark for the exponent. Is we write down, so we write down log for log coming from logarithm, of course. So we've got log coming from logarithm, and then we're going to take this 2 that's our base, and we're going to throw it down there as like a subscript. So make sure it's smaller and a little bit below the rest of the letters. Log base 2, so right, this is our base, so we would read this as log base 2, but log base 2 needs to have something in brackets, something that, you know, a math major might call the argument. We can, if we're thinking about it in terms of this, we could say the answer is the number that you put in these brackets here. So if we're looking at this question here, you've been given the base, which is 2, you've been given the answer, which is 4, and the way you would write that out in the proper notation is log, L-O-G, for logarithm, base 2, so that 2 came from this base, and then this answer we chuck inside the brackets, and that's called our argument. So it's log base 2 of 4. That's the way you would read this, is log base 2 of the number 4 is equal to what? And that's the answer that we want to calculate. So basically, the answer to a logarithm question is the exponent in this equation right here. So this question mark in our final answer over there is the same as this question mark in our exponent over here. That's basically what we're trying to answer with a logarithm. So what this logarithm is asking us, if we look at our definition in words, is how many of one number. In this case, the number that we're going to be multiplying together over and over again is, when you write it out this way, is the little guy down here. So in this particular question, it's the number 2. How many of the number 2, that's the one number that we're multiplying over and over again, do we have to multiply together? How many of those do we have to multiply together to get another number? How many of these little 2's down here do we need to multiply together in order to get an answer of 4? Alright, so if you're asking how many times you need to multiply the same thing by itself, if the answer was 2, then that means you're squaring the number, right? Which means that if your answer is 2, that means you could put a little 2 up here for your exponent, and you get 2 squared equals 4. If your answer happened to be to something different, if it happened to be 3, that means you'd put a little 3 up here, and it would be 2 cubed is equal to, well, it wouldn't be 4, it would be 8, but you would just sort of go on with, so you'd take whatever answer that gets, that gives, and put it up here in your exponent, and then that should give you the final answer. Obviously, you wouldn't have to go and calculate the final answer because the final answer has been given to you. But yeah, so if you look at this question here, I lost my train of thought. Where was I going with this? If you look at this question here, if you just read the question, it's using the lingo of exponentiation. It's asking you to find an exponent. How many of one number do we have to multiply? Basically, how many of one number do we have to multiply by itself? So that's exponentiation. That's, if you write it in this form, that's basically what it's asking. 2 times itself, how many times is going to give us 4? 2 multiplied by itself, how many times is going to give us 4? That's what we're asking, and we've just rewritten it in this different form. So this is log base 2 of 4 is equal to what? Alright, so let's go ahead and actually figure that out. This one is a fairly straightforward example, but this is something that, for the most part, if the numbers don't work out very nicely, it's something that you would tend to use a calculator for. Like, I would just use a calculator for most logarithm questions, unless it's one of the relatively easy ones that you can calculate, like this one. So basically, this question, I'll say it one more time, is asking us, because we've got this base of 2 down here, this question is asking us how many 2's do we need to multiply together to get an answer of 4. Alright, that's the question. So basically the way you can go about figuring that out for these easier examples is just start by multiplying 2 of them together, or really start by looking at just one of them, right? 2 by itself is definitely not equal to 4, right? If this number down here and that number up there were the same, then I don't need to multiply anything at all, right? If this was log base 2 of 2, right? If this was something like log base 2 of 2, then that's asking me how many times do I need to multiply 2 together in order to get an answer of 2. You don't need to multiply it together at all, so your answer would be 1. But we'll come back to that a little bit later on. So for now, we'll start with, assuming those two numbers are different from each other, start off by just multiplying 2 of them together and see what you get. So your base is 2, so we'll do 2 times 2, and we get 2 times 2 is equal to 4. Right? This is a fairly simple example, so right off the bat, we've got our answer. Our target answer was 4, and right off the bat, we've got that. So once you've got your target answer here, you can just look back and ask yourself to check how many of those 2's did I have to multiply together in order to get 4. So over here we multiplied 1 and 2. We took 2 2's and multiplied them together to get 4. So because we multiplied 2 of them together, our final answer for this logarithm would be 2. And you just throw a 2 after the equal sign and you'd be done. Alright, so that's a really straightforward example. Let's do one that's going to be slightly more involved. First we'll do one actually that's kind of equally simple, just to see if you can figure out the notation for yourself. So let's do one that's slightly different. This one will be the logarithm base 4 of 16. Alright, that's the question. So if we rewrote this in that sort of exponent form, our base is going to be this 4 right here. And that, when you read it out, that's how you would say it. It's log base 4. So because we're saying base 4, that's sort of a little bit of a clue for us when we want to rewrite it in that sort of exponent form. That's going to be 4 to the exponent something. That exponent is what we're looking for. So we'll put a question mark there. You could put your favorite letter. You could put a sad face or a smiley face or something to indicate that that's what you're looking for, is equal to, and then you take that 16 over there and throw it over on the other side of the equal sign. So this is the question that we're asking ourselves. 4 to what exponent is going to equal 16? Is it going to be 4 squared, 4 cubed, 4 multiplied by itself 5 times, 10 times, 20 times? That's what this question is asking us. How many 4's do we need to multiply together to get to 16? And so the way you can solve it for these easier examples is just start by writing out a couple of them. 4 times 4 is equal to 16. Well, we've just hit our answer. That's the answer that we were targeting this with this question. So now that we've hit our target answer, we're just going to look back and see how many 4s did we multiply together. And in this case, just like in the last one, we multiplied 2 4s together, so our answer would be 2. And you can go ahead and double check. If you put a 2 up here in your exponent and you calculate 4 squared, you should get 16 as your answer. Alright, but that's not really more involved than the last one at all, aside from translating this new notation into something that's perhaps a little bit more familiar. Let's do one that's slightly harder. So we'll change the base. I'm going to get rid of the 16, and I'm going to get rid of that 2, and I'm going to get rid of those. And we'll make this one log base 5 of 125. So, in order to set this up in a more familiar looking form, we know it's going to be base 5, right? If you read this out, it would be log base 5 of 125. So, if I wanted to rewrite this in a more familiar form, I'll say 5 to some exponent, you can put a question mark or a sad face or a smiley face, 5 to some exponent is equal to 125. Now, if you don't know it off the top of your head, we'll just go ahead and multiply a few 5s together and see what happens. So we'll start off by taking 2 of them. We'll do 5 times 5 and see what that gives us. Well, 5 times 5 is 25, but our target is 125. So 5 times 5 is not going to be enough. Let's throw in another 5. So if we do 5 times 5 times 5, well, we already know that the product of these first two is going to be 25. So what we're really doing is 25 times 5, which, if you go ahead and calculate that, is going to give you 125. So that 125 there is our target answer, right? That's what we were looking for over here. So once we've hit that target answer, we just want to go back and count how many 5s did we have to multiply together to get to this answer. So if you look up here, we've got 1 5, a second 5, and a third 5. So we multiplied 3 5s together to get our answer of 125. So your final answer in this logarithm would be 3. Or if you wanted to write it in this exponent form, your exponent up here would be a 3. 5 cubed is equal to 125. Alright, hopefully that's making sense. We'll do one that's a little bit more involved, sure, why not? And then I'll show you a couple of special sort of tricks with logarithms, and then maybe another time we'll come back and we'll do some more practice problems. But next one we'll do is, let's do log base 2 of 1024. We want to know the answer to that. So, if we sort of break down this notation, what it's trying to tell us is, or what it's trying to ask us is, how many 2's do we need to multiply together to get to 1024? So we'll start with just 2 times 2 and see what that gives us. So we've got 2 times 2, that is going to equal just 4, right? That's not enough. So we'll throw in another 2. 4 times 2, so 2 times 2 times 2, that's going to equal 8. It's going to get really messy if I keep writing these down, so maybe what I'll do is I'll just write the product sort of down below here. So 2 times 2, that would give us 4, right? That's not enough. 2 times 2 times 2, that's 2 times 2 is 4, times 2 is 8. Still not enough. So I'm going to cross that out. We'll throw in another one. 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. Not good enough. Multiply in another one. 2 times 2 times 2 times 2 times 2. So far this is 2 to the exponent 5 is what we have written out here, and that's going to equal 32. Still not enough. We'll throw in a couple more. 2 times 2 times 2 times 2 times 2 times 2. That's 2 to the exponent 6 is going to give us 64. So if you notice here, we're just doubling every time, right? We technically started with a 2 over there, wasn't good enough, so we multiplied it another 2, gave us 4, then we got 8, 16, 32, 64. So I'll add in another 2, and I'll double this, and that'll give me 128, which is bigger, but it's still not enough, right? Let's multiply in another one. Times 2, that's going to give us 256. Still not big enough, but we're getting closer now. So right now we have 1, 2, 3, 4, 5, 6, 7, 8. Right now we've got 8 2's out here. So this is 2 to the exponent 8 is 256. Let's multiply in another one. So if we double this, you can go ahead and calculate that. Should give you 512. So that's with 9 2's there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So right now we've got 2 to the exponent 9 is equal to 512. But that's still not big enough. So let's multiply in one more. And if you go ahead and do that multiplication, that should give you 1024 as your answer. 512 times 2 should be 1024. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 2's out here. So we've got 10 2's multiplied together, means that 2 to the exponent 10 is equal to 1024. Now 1024 is our target number, right, for this question. And our base is 2, that part matches. The answer to the logarithm is that little exponent in there. What exponent do I need to raise this base to get that target answer? So how many 2's do I have to multiply together to get to 1024? And the answer is in our exponent up there, or you could simply count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your answer to this logarithm would be 10. Alright, hopefully that's making sense. I'll give you guys a sec to digest that. And then we'll just talk about a couple of neat tricks with logarithms. Yeah, we got time. Yeah, so a couple of properties of logarithms. Let me get rid of this problem here. So actually I'll go back to the thing that I was mentioning earlier, is that if you have logarithm base, let's say 3 of 3, what's that answer going to be? Well, if we break this down to the same form as before, we've got base 3, so it's 3 to some exponent is equal to, and this is our target answer, so 3. So basically we're asking ourselves 3 raised to what exponent is going to give us an answer of 3? Well, I already had 3 here. I don't need to multiply any more 3's into this, so my exponent would be 1, right? 3 to the exponent 1 is the same as just the number 3. So my answer to this would just be the number 1. But now, let's say the base wasn't 3 and the argument wasn't 3. Let's say they were both 2's. Now what's the answer? Well, now what we've got is we've got base 2, so it's 2 raised to some exponent, is equal to 2. And it's the same deal as before. 2 is already the answer that we were targeting, so I don't need to multiply any more 2's into this. So it would just be 2 to the exponent 1 is equal to the number 2. So this works for anything. So log, I'm going to write an a down here. A, you could say for any number. Log base a of a is going to equal 1. Right? So the reason that works is, basically what this is asking you is, you have any number a. I don't care what it is. Could be 2, could be 3, could be pi. I don't care what it is. A to what exponent is going to give you an answer of a. That's what this logarithm up here is asking us to find out. And so no matter what the number is, if you've got the base here and your target answer are the same thing, the exponent's just going to be 1. So this is true if the base and the argument, remember this is the base and that's the argument, if these two are the same number, your answer is just 1. You don't even need to calculate anything. So that's something that's useful and reasonably simple property of logarithms. We'll get to a couple more complicated ones, but I think I'm going to leave those for the next video because I want to highlight one more property of logarithms. And that is, if I took the number 3 and I raise it to the exponent 0, I'm going to get an answer of 1, right? Because we talked about it when we were dealing with exponents. If you've got an exponent of 0, your answer simply is 1. Right? If it was 5 to the exponent 0, it's still going to be 1. If it was 100 to the exponent 0, I'm still going to get 1. If it was 1024 to the exponent 0, I'm still going to get 1 as my answer. So, what we're learning here is that if your answer is 1, it doesn't matter what the base is, your exponent has to be 0. Right? If my base was 25, and I'm raising it to some exponent to get an answer of 1, it has to be the exponent 0, because that's what's going to get me down to exactly 1 as a final answer. So log of any base, so I'll put another a down there, that could be any number down there. If your argument is 1, if the number in here is 1, that's our target answer, that's that target answer, and that one, and that one, and that one. Notice that we don't care what the base is, that's why I've put an a down here. Log of any base of the number 1 is equal to 0, because the 0 is that exponent in there, and that 0 is constant every time. Any number to the exponent 0 is equal to 1. And so log base a, any number, of the number 1 is equal to 0. So that's a second semi-useful property of logarithms. This might pop up perhaps on an assignment, but if you end up doing more advanced math down the years, then you'll eventually come across problems where these two can just simplify your life a little bit. So it's quite handy to know. Normally the lessons are a couple minutes longer than this, but I don't really like them to be that much longer. So I'm going to cut this one off here, and then in the next lesson we'll talk about a couple of properties of logarithms, and we'll do some practice problems. First, a few that are just dealing with finding the answer to a basic logarithm question, and then we'll start making use of those properties of logarithms in some more complicated questions. So the next 2 videos, I think, are going to just be those practice problems, and after we introduce the properties of logarithms, then working with those as well. So there are a couple of useful properties that we still haven't talked about. These are sort of the 2 really basic ones, and then there are 2 or 3 more advanced ones that we'll get into. And then yeah, after that there'll be a test review, and that'll be it for this unit. I know this stuff might not be something that you've seen before. The things that we were doing before this in the unit are things that you might have come across in the past, but this might be entirely new. So if you are struggling with it, or if you want extra practice problems or something like that, get in touch with me. Otherwise, I will see you in the next video. Have a good one.